All right, today we're going local. Well, cosmically local, anyway. We're about to take a deep dive, a guided tour of our home address in the universe, the incredible, magnificent spiral of stars, gas and dust that we call the Milky Way.
Just think about that for a second. Right now, you're hurtling through the cosmos on this tiny little planet, orbiting just one of hundreds of billions of stars inside our galaxy. So, what does our cosmic neighborhood actually look like? How does it all hold together? Well, let's jump in and find out.
Okay, first things first. Before we go anywhere, we need to get our bearings. To really understand our place in all of this, we need a good, clear picture of what the Milky Way actually looks like. Think of it as our galactic self-portrait. So our galaxy basically has four main parts. The easiest way to picture it, think of a giant cosmic fried egg. You've got the bright, flat disk. That's the egg white. It's where we live, along with most of the young stars and all that gas and dust. Right in the middle is the bulge, kind of like the yolk, which is this dense ball of older stars. And then surrounding the whole thing is the halo, a huge, almost ghostly sphere that's home to the galaxy's most ancient stars. And a lot of those old-timers are gathered in these super tight, city-like clusters called, you guessed it, globular clusters. Now, here's a key thing to remember. Because we're inside the disk, our view is totally different. We see the Milky Way from the side, edge on. And that's why, on a clear night, it looks like this faint, milky band of light stretching across the sky. But if we could somehow travel hundreds of thousands of light years away and look down on it from above, we'd see the whole magnificent show, the breathtaking spiral arms that we see in pictures of other galaxies. So we've got the basic shape down, but, a galaxy isn't just a static object sitting in space. It's a bustling, dynamic city of stars. And just like any big city, it has its own traffic patterns. And that's what we're going to look at next, this great cosmic dance. The stars in the disk, stars like our own sun, mostly move in the same direction in these really orderly circular orbits. It's a lot like cars on a racetrack, all flowing together. But the stars in the halo and the bulge, they're a completely different story. Their orbits are totally random, plunging through the disk at crazy speeds from all directions. It's less like a racetrack and more like a chaotic swarm of bees. Now this difference, this isn't random at all. It's a massive clue about our galaxy's hidden history. But let's zoom back in on those disk stars for a second. We said they move in an orderly way, but they also have this slight up and down bobbing motion. So what's causing them to do that? Why aren't their orbits perfectly flat? The answer is gravity. You see, as a star's orbit carries it a little bit above the main plane of the disk, the combined gravitational pull from all the other stars and gas in the disk pulls it right back down. Then, when it passes through to the other side, it gets pulled back again, and this creates a gentle cosmic bobbing motion that plays out over millions and millions of years. And that constant gravitational pull, that cosmic tether, is actually part of a much, much bigger story. It points to a really crucial idea. Our galaxy isn't just a static collection of stars. It's a living, breathing ecosystem. It's constantly recycling old material to build something new. This whole process is called the star-gas-star cycle, and it is the engine that has kept our galaxy alive and churning for billions of years. It recycles the very elements, the carbon, the oxygen, the iron, that eventually clump together to form planets, and, even the atoms inside your own body. So this slide here just maps out that whole amazing process. It all starts inside stars, right? They act like these cosmic forges, creating heavier elements. Then, when those stars die, they blast all that enriched gas back out into space. That gas eventually cools down, starts clumping together into these massive clouds, and then gravity does its thing, collapsing those clouds to form a brand new generation of stars and planets. And then, the whole cycle starts all over again. Now, this recycling has been happening for billions of years. So that raises a really cool question. If the galaxy is constantly changing, how in the world can we know what it was like at the very beginning? Well, the answer lies in cosmic fossils, these ancient ghost stars that have been around since the dawn of the galaxy. By studying these old stars out in the halo, we can basically perform a kind of stellar forensics. See, these halo stars are ancient, and they have very few heavy elements. That's anything other than the basic hydrogen and helium that came from the Big Bang. But disk stars, like our sun, they're much richer in all that heavy stuff. And that, right there, that's our smoking gun.
It tells us that the halo stars had to have formed first from the universe's original gas before countless generations of other stars had a chance to cook up heavier elements and seed them throughout the galaxy. So, with that evidence, we can actually piece together the Milky Way's origin story. It probably started as this gigantic primordial cloud of gas. As gravity started pulling this cloud together, the very first stars, those ancient halo stars we just talked about, ignited within it. The rest of the gas, which had a little bit of a spin to it, flattened out into the disk that we see today. And that's where star formation has been chugging along ever since. Okay, for the final stop on our tour, we are heading to the most extreme, the most chaotic, and the most mysterious place in our entire galaxy, the very, very center. For decades, astronomers knew something really weird was going on at the galactic core. The problem is, it's totally hidden by thick clouds of gas and dust, so we can't see it with regular telescopes. So the big question was, what on Earth could possibly be lurking back there? So using infrared and radio telescopes, astronomers were finally able to peer through that veil. And the evidence they found was just mind-boggling. They saw stars whipping around a single empty point in space at unbelievable speeds. They saw these powerful flares of X-rays suddenly erupting from nothing. And whatever was at the center, it was completely and utterly dark. When you put all those clues together, they all point to one inescapable conclusion. There is a single, invisible object at the center with a gravitational pull that is just immense. And by tracking the precise orbits of those stars, astronomers could actually calculate the mass of whatever was pulling their strings. The number they came up with is staggering, 4 million. That's 4 million times the mass of our entire sun, all crammed into a space smaller than our own solar system. There's only one object in the entire universe that can be that massive, that compact, and that dark. A supermassive black hole. The monster in the middle of our galaxy, the gravitational anchor for billions of stars, is a black hole of truly epic proportions. And that's where our tour ends. We've seen that we live in this incredible galactic city that builds new stars from the ashes of old ones, a place where the traffic patterns of stars reveal a hidden history, and that's all held together by a monster hiding right at its heart. It really makes you wonder, what other secrets is our magnificent galaxy still waiting to reveal?